Hi, in this Let's Create series we're implementing the core game mechanic for a range of simple games. In this episode we're doing Asteroids. You've got a spaceship which you can turn, shoot and move, and an ever-increasing number of asteroids that when you destroy them they split into more asteroids. Everything wraps around the screen and it's exactly as you remember it. Let's get started. I'm starting with a new Unity 2D project called Asteroids. The first thing we're going to do is to get the player movement sorted. Create this spaceship by right-clicking, 2D object, sprites, triangle. We'll call this player. I'll just move it over here so we can see it better. Let's shrink it down. I think 0.3 on X and 0.6 on Y looks good. We're going to use physics to handle the movement, so add a rigid body 2D. We'll set gravity scale to 0 because we don't need that. Whilst we're here, we'll add a polygon collider 2D as we'll need to detect later if we hit an asteroid. We'll check the is trigger box as we just want to detect collisions rather than have them interact with physics. Now we'll create the script to handle the movement. Create a new folder called scripts and add a new C# script called player. We can drag that onto the player and dive into the code. Firstly, we'll create some variables to hold the movement parameters. These are all private, but we expose them to Unity using serialized field, so we can tweak them easily. We have a float for the ship acceleration, which I set to 10, another float for the ship max velocity, which I've set to 10. We want to limit the ship velocity, as otherwise the game gets a little crazy. Finally, a ship rotation speed to control how fast the ship turns around. The remaining variables we'll create as we go along. The start method is nice and simple. We just use getComponent to get our reference to the rigid body 2D. So we need to add a private rigid body 2D called shipRigidBody to hold this in. In the update method, we'll do two things: handle the ship acceleration and handle the ship rotation. These both only happen if we're alive. So add a private boolean called isAlive, which will default to true. We can now wrap the two functions in update with a check for isAlive. I've broken this out into functions to keep the update method nice and tidy. For handle ship acceleration, we're going to check if the user is pressing the up arrow. We use getKey here because we want this to trigger continuously so you can hold it down. Create a new boolean called isAccelerating and assign the result to this. This will be true when we're pressing the key and false otherwise. We don't actually add the false here in update and just set the boolean because all the physics simulation should be done in fixed update. So we'll add the fixed update method. Here we can check that the player is both alive and the isAccelerating boolean is set. Then we can use the addForce method on the rigid body to add our force, and this will be the ship acceleration in the forward direction, which we can get by multiplying it with transform.up, which, as this script is attached to our player, is pointing towards the front of our ship. We don't have any drag in space, so we could accelerate forever. So we can limit the velocity using the vector2 clamp magnitude function, passing in the ship velocity and our ship max velocity we set up earlier. This will stop our ship from going insane speeds. Now for the handle ship rotation method. This again uses input.getKey, so it will work when we're holding the keys down, and we use left arrow and right arrow as our keys. For these, we want to rotate the ship. So we get the transform of the current object with transform, and we use the rotate method to apply a rotation. The rotation amount is our ship rotation speed, which we'll multiply by time.deltaTime to get the proportion we want to apply since the last update. We then multiply this by transform.forward to give us our desired rotational axis. For the right arrow, we just negate the ship rotation speed to get the rotation in the other direction. Let's jump back into Unity and see this in action. Pressing left and right rotates our ship, and the up arrow sends us accelerating off. It even has that uncontrollable feel I remember from playing Asteroids as a kid. Exiting play mode, we'll just click on the main camera and change the background colour to black. That's much more fitting for the game. The problem we have now is that when the ship goes off the screen, it doesn't wrap around like you expect. So let's fix that now. Create a new C# script called wrap and drag that onto the player. We've created a separate script for this rather than including it on the player because we'll want the same logic to apply to the bullets and the asteroids later. This is a very simple script containing just the update method. Using the transform of the game object for which this script is attached, we can get the position. The first thing we do is change this from world coordinates to viewport coordinates. This can be done with camera.main.world to viewport point. The viewport coordinates maps the values onto a 2D plane between 0 and 1 regardless of the screen aspect ratio. This makes it very easy to tell when it goes off the screen. We start with our movement adjustment set to 0. Then if we've gone off the left side of the screen, that is x is less than 0, we want to add 1 to it to move it back to the right. If we've gone off the right, we subtract 1. And similarly for the vertical direction, if our y position is less than 0, we've gone off the bottom, and we add 1 to the y coordinate. Finally, if we've gone off the top, we subtract 1. The reason we've done it like this is that you go off the bottom and the left at exactly the same frame. We want to update both the coordinates together. We can then add our movement adjustment to our original viewport position, and using the opposite function on the camera, viewport to world point, to get back into world space, which we assign to the transform that this script is attached to. That should all work now. Let's check it out. If we accelerate off the top, we wrap down to the bottom. Similarly, going off the right wraps us to the left. All is working as intended. Now we'd like our ship to shoot some bullets. So right-click on our player and create an empty game object. We're going to use this to dictate where the bullets will spawn from, so call this bullet spawn. We'll move this to the top of the ship so they spawn out of the front. To create a bullet, right-click, 2D objects, sprites, circle. Call this bullet and I'll set the scale to 0.1 on the X and Y to make this a good size. We'll add a circle collider 2D, which like the player, will create as a trigger. Add a rigid body. Again, remember to set the gravity scale to 0 as we don't want to use that. In our scripts directory, create a new C# script called bullet and drag that onto our bullet. Now let's create a folder called prefabs and drag the bullet in there. We can now delete this from the scene and create the new bullet script. The bullet.cs script is super simple. We'll create a private float, which we'll serialize so we can change it in the inspector if you like, called bullet lifetime, which I default to 1 second. Then we'll use the await method, which is called when the bullet is created. Here we'll call destroy. Pass in game object, which is the object this script is attached to. The second argument is a delay on which to call this, which we pass in our bullet lifetime. What this means is after creating a bullet, it will get destroyed after 1 second. Now to create the bullets, over in the player.cs script, we'll add the reference to these objects. I use another header to differentiate these in the inspector from the ship parameters. Then we want the transform for the bullet spawn, and we'll use this to set the position of the bullets when we create them. Add the rigid body 2D component of the bullet prefab, as we'll want to apply the velocity to the bullets. When adding references to Unity game objects like this, you can use whatever component you want as the type, and Unity is smart enough to ensure it passes the correct thing for you. I will also, for our ship parameters, create a new private float called bullet speed, which I'll default to 8. In our update method, we'll add a third method called handle shooting. In this method, we first check if we're going to press space. This time, I'm using get key down because I want the player to have to press space each time to fire a bullet. We instantiate our bullet prefab into a rigid body 2D variable called bullet. The second parameter to instantiate is the location, so we use the bullet spawn dot position, and the third is the rotation, which we don't want to change, so we just use quaternion dot identity there. Now we need to add some force to the bullet to send it on its way. The natural first attempt to do this would be simply to use add force. The first parameter is our bullet speed multiplied by transform.up, so it moves out of the front of the ship. And we use force mode 2d.impulse to add an instant force to the bullet. As you can see by the preview here, this works fine when the ship is stationary. However, if you're moving forwards, you can be moving faster than the bullet, which doesn't look so good. So we want the bullet to inherit the velocity from the ship. If we do this with accurate physics, then we're going to have another unwanted side effect. If you are flying at bullet speed and facing backwards, then the bullets will come out of the ship stationary. Whilst this is physically correct, it doesn't make for a fun game. So instead, we'll only inherit the velocity in the forward direction to avoid this issue. So we'll get the ship velocity using the ship rigid body dot velocity and the direction we are facing, which is transform.up. To calculate the speed in the direction we are facing, we can use the dot product. I'm not going to go into the details here, but if you're interested in doing physics in games, I strongly recommend learning more about vector mathematics. This will give us a positive speed if we're facing in the same direction as we're moving, and a negative one if we're facing away. So to get the effect we want, we only want to apply this velocity to the bullet if we're going in the same direction. So if it is less than 0, we can just zero it out. Then we can set the bullet's initial velocity before we add the force. So the initial ship forward velocity will be the ship forward speed multiplied by its direction. Now back in Unity, we need to add the bullet spawn and the bullet prefab references to our player. Then we can try it out. This now works as we expect. The bullets come out in the same sort of way, whichever way we're facing, no matter how fast we're going. As I said, it's not accurate physics, but it makes the game much more playable. You'll notice that if you shoot the bullets off the screen, they don't wrap around like they should. This is a simple fix. All we have to do is select our bullet prefab, add a component and select our drag script. Alternatively, you could have dragged it on. That's now all working great. The final core element of the Asteroids gameplay is obviously the asteroids. So the first thing we do is create a new directory called Sprites. Then drag our asteroid graphics into this folder. You can find a link to this in the description below, or you can create your own. Let's drag that onto our hierarchy and rename it Asteroid. To this, we'll add a Polygon Collider 2D. This will give us a collider that approximates our sprite's shape. As before, we'll set isTrigger as we only want to detect collisions, not simulate them with physics. Also, we'll add a rigid body 2D and set the gravity scale to 0 like we did for the others, as we don't want any gravity. In the scripts folder, we'll drag on the wrap script as the asteroid should wrap around the screen. You can drag the script onto the object in the hierarchy or the inspector as I've just done here. Then create a new C# script called Asteroid, which will also add to our asteroid object. Let's jump into the asteroid code. This will be the same script and object we use for asteroids of differing sizes. As such, the first thing we'll want is a public int size, which defaults to 3. This is public because we'll be setting this when we instantiate the asteroids later. We use 3 as the starting value because that's how many sizes of asteroids we have when it splits apart. So in our start method, the first thing we'll do is set the size of the asteroid depending on the size. We set the transform.local scale to half of the size, then multiply this by the unit vector. We need to do that last bit so it sets all the dimensions. The half in there means that our asteroids will be roughly 1.5 units originally, then 1, then 0.5, which looks about right to me based on the size of our sprites. Next, we want to give the asteroid some movement. Get a reference to the rigid body 2D using getComponent, as we'll use physics to add the velocity just like for the player. We want the asteroid to move in a random direction, so create a new vector 2 called direction. This is constructed with a random value for the x and y directions using random.value, which gives us a random float between 0 and 1. These vectors will have different sizes, so we use .normalize to make sure the direction is a unit vector. Then for the speed of the asteroid, we want the game to have a bit of variation so not all the asteroids are moving at the same speed. As such, we'll set the spawn speed to be a random value between two values, based on the size of the asteroid. The formula I've used here is 4 minus size for the start of the range and 5 minus size for the end. The larger asteroids with size 3 will move between 1 and 2, and the smaller ones of size 1 will move between 3 and 4. This dynamics gives the game a good feel, I think, but you can adjust this to your liking. Finally, we call add force on the rigid body with our random direction multiplied by the spawn speed as the force. Again, we use impulse as the mode as it's a single application of force. That should be enough to get our asteroids moving. Let's jump back into Unity and check that out. That's all working great. The asteroid moves in a random direction at a reasonable speed. It also wraps around the screen. Exit out of play mode and we'll drag our asteroid into the prefabs folder and remove it from the scene. What we'll do now is get our game manager set up to spawn the asteroids for us. Then in the scene, we'll create a new empty game object called Game Manager. So in the scripts directory, create a new C# script called Game Manager and attach the script to that. The very first thing we're going to need to do with the Game Manager is to keep track of how many asteroids there are. Create a public int called asteroid count, which starts at 0. In our update function, each frame we're going to check if there are no asteroids remaining. If that's the case, we've gone up a level. So create a private int level, which starts at 0, and we'll increment this in our if statement. We are now at level 1, and we want to spawn 4 asteroids. Each level we go up, we spawn 2 more asteroids, so the game gets harder and harder as you progress. To do this, we'll define the number of asteroids as 2 plus 2 times the current level. That will give us 4 for level 1, then 6, 8, 10, etc. as we go up in levels. Use a for loop to iterate num asteroids times, and each time we'll call a function spawn asteroid. What we're going to do is instantiate an asteroid, so we need to create a serialized private asteroid called asteroid prefab to get a reference to the asteroid. Then, in our spawn asteroid method, the main job is to instantiate the asteroid prefab at some location called world spawn position. What we need to do is calculate where we're going to spawn it. The random speed and direction will be set when the asteroid is created, and we could have done the random position in the asteroid start method too. The reason I chose to do it in the game manager is because maybe you don't want it to be fully random, but to ensure that the asteroids are all spaced out around the screen. As such, you need to know where all the other ones have gone. However, for the basic game here, we're just going to do it randomly. First thing we'll do is create a random value between 0 and 1, which will be our offset on the edge of the screen to spawn the asteroid. We're going to use viewport coordinates here because they helpfully go between 0, 0 and 1, 1, which makes things easy. So create a vector 2 called viewport spawn position, which will default to 0. We've already got our offset, which says how far along the edge it's going to be, so all that remains is to choose an edge. So our int edge will be a random number in the range 0 to 4, i.e. 0, 1, 2, or 3. If the edge is 0, we're doing the bottom edge, where we set the spawn position as x equals our offset and y equals 0. Edge equals 1 is going to be our top edge, so same again, but y equals 1. For edge equal to 2, it's the left edge, so we'll do x equals 0 and y is our offset. And finally, for edge equal to 3, it's going to be the right edge, so we'll have x equals 1 there. We can then use the helper on the camera called viewport to world point to convert this value on the viewport to world coordinates. This world spawn position is the value we're passing to our instantiate function. This would work and spawn asteroids, but we haven't incremented our num asteroids variable, so it keeps spawning each frame. We could add this here, but it's actually better to add it in the asteroid code. This is because the asteroids are going to spawn more asteroids when they break up, and at that point it's easier to handle this in the asteroid code. So what we'll do is add a game manager reference to the asteroid, so they can tell it when it spawns asteroids. For now, let's assume we've done it and just set the game manager on the asteroid we've just created to the current game manager script with the this keyword. Now let's jump into the asteroid script and add the game manager reference in. We'll create a public variable of type game manager called game manager. And all we'll do is at the bottom of the start method, after we've done all the movement, we'll register the asteroid with the game manager. We do this simply by updating the asteroid count. The plus plus operator here is shortcut for writing asteroid count equals asteroid count plus 1. That should be sufficient for this to be working now. Let's jump back into Unity. On our game manager script, we need to drag in the reference to the asteroid prefab. Now hit play and see what we've got. We've got 4 asteroids spawning at random points around the screen and moving randomly. Excellent. Now all we need to do is to sort out the triggers so our bullets can destroy the asteroids, and if the asteroids hit our player, it's game over, as at the moment everything just passes straight through. We'll start with the asteroid code. As we set the isTrigger property on the collider, we will add a new onTriggerEnter2D method which has a collider2D as a parameter. This will be triggered every time another collider interacts with our object, and the thing that collided will get passed into the collision variable. We don't want every collision to destroy the asteroids, just the bullets. In some versions of the game, the asteroids can destroy each other, but I think it's better if they don't. So we're going to use the compare tag option on the collision object to see if it is a bullet. We'll assign this tag once we're finished in the script. First thing we're going to do is register with the game manager that we've destroyed an asteroid by decrementing the count. Then we'll destroy the bullet that hit the asteroid by calling the destroy on the game object associated with the collision. This is so that it doesn't carry on and keep hitting asteroid after asteroid. If the current asteroid size is greater than 1, we want to spawn more asteroids of a smaller size. In this case, each asteroid splits in 2, which I think matches the original Asteroids game. So we use a for loop with a limit of 2 to instantiate a new asteroid. We can just pass this as the first parameter and duplicate this asteroid. We use the asteroid component for the duplication because we need to change a couple of parameters on there. First is to set the size to 1 less than the current asteroid, which makes sure they get smaller. We also pass a reference to the game manager so it can register itself so that we have an accurate asteroid count. And finally, we destroy the game object of this asteroid as we don't need it anymore. So back in Unity, let's go to our bullet prefab and add a new tag. It's here on the left beneath the name of the object, and we can choose add tag as there isn't one we want to use. Use the plus button to add a new one called bullet to match what we had in our code. Then you can click on the bullet prefab and select this new tag from the list. That should be enough. Now let's start the game and check it out. We can now destroy asteroids, and each time we get 2 smaller, faster versions. When we destroy the smallest ones, they disappear and no new ones are spawned. I'm not the quickest at this. Then, when we've destroyed them all, more spawn in. The last thing to do is handle the interaction between the player and the asteroids to actually make this difficult. Like with the asteroid, we'll add an onTriggerEnter2D method. This time, we'll compare the collision with the tag asteroid. We don't want our own bullets to kill us. Though if you want to make it harder, you can include them too. Now we don't have the game manager as a reference on the player. You could add one in. I'll just show you another method of finding references to objects. In this case, we can use the find any object by type with the game manager type. This is more computationally expensive than assigning the reference ourselves, but this isn't time critical and it's such a small game that it really doesn't matter. We'll call a new method from the game manager, which we'll call game over. Then we can destroy the player. Over in GameManager.cs, we first need to add 2 new imports at the top. System.collections, so we have access to the IEnumerator type we need for the coroutine. You may already have this. And UnityEngine.cManagement, which we'll use to reload the game. So create a new public method called GameOver, which is what we called from our player. We don't want to restart straight away, so we'll put a delay in here. So we call start coroutine and we'll pass in yet another new method called restart. We couldn't call the coroutine directly from the player, as when we destroy the player, it would also destroy the coroutine. This is a coroutine, so we use the IEnumerator type. First, we'll just log out to the console a debug message. You can obviously show a game over screen at this point. Then we'll yield a new wait for seconds object, and we'll pass in 2 to wait 2 seconds. Then you can use scenemanager.loadScene method to load a scene. You could pass in 0 here, which will be the build index of this scene, as we only have one. Or better yet, you can use the getActiveScene method and use the build index parameter. And that's it. We're done with the core gameplay. Back in Unity, we'll add a second tag called Asteroid. Then on the Asteroid prefab, we'll assign it to the Asteroid tag. Now when playing, if the asteroids hit us, the player disappears, and after 2 seconds, the scene starts again. Let's just show the console so you can see the game over message too. Normally, I leave the extra effects to you. However, I thought this looked a little bit flat, so I'll add a simple particle effect that really brings this to life. We'll create an effect to be shown each time you destroy an asteroid or if the player is destroyed. So right-click, Effects, Particle System, and we'll call this Destruction Effect. Let's pull that duration down to 1. This doesn't have any effect right away as we're just constantly emitting particles. So we'll go down to emission to change this. Set rate over time to 0 to stop the constant emission, and we'll add a burst. Use this plus icon to create a new one, which defaults to a count of 30. We'll keep it like that, and you can see now once a second it does a burst. They are, however, going the wrong way. So we can change the rotation on the game object to 180 so it's pointing in the right direction. The default particle system always puts the emission shape as a cone. We want them to appear from a point. So in this shape tab, change the shape from cone to circle, and then drag the radius right down to effectively 0 to give a point. The particles are hanging around a bit though. We want it to be a bit more bursty, just like an explosion. So we'll change the start lifetime from 5 seconds using the little white triangle to choose random between 2 constants and set the values to 0.4 and 0.5. Now it's much shorter and there is a tiny bit of variation in there. It's still quite uniform, so we'll do the same thing for the start speed. Again, random between 2 constants and set it to between 1 and 4. At the moment, they disappear quite abruptly. Instead, we'll fade them out. Go to the Colour over Lifetime tab and open up the dialog by clicking on the white box. The top triangles are to do with the alpha and the bottom 2 with the colour, with the left side being what it is at the start and the right side at the end. So click on the top right triangle, then set this to 0, so we're going to fade from white to transparent. As the asteroids and player are likely to be moving, one thing to add in is the Inherit Velocity tab. So we'll set the initial velocity with a multiplier of 1, so it will inherit any movement. The problem we have at the moment is that each particle is a fuzzy blob, and that doesn't fit well into the retro style of the game. So we'll create a new material for this. Create a folder called Materials, and create a new material in the right-click menu. Call this Particles. Then change the shader from Standard to Particles Unlit. We'll also change the rendering mode from Opaque to Additive. This gives us 2 things. Firstly, this enables a transparency, so our fade out works, and the additive nature means that overlapping particles, as they fade out, they add together and appear brighter. This gives quite a nice effect. We can then drag this particle material into the Material section on the Renderer tab. It's a bit big, so we'll set the start size down to 0.1. Then we're done. We can drag this into our prefab folder and delete it from our scene for now. I've just remembered we've forgotten 2 important things, but we can add these now onto the prefab. Firstly, let's turn looping off. We only want the effect to show once. And we also want to set the stop action to destroy. This means once our animation has played, the game object is destroyed, so we don't have lots of particle effect objects cluttering up our game. Let's jump into the code and spawn this in. In the asteroid.cs file, we'll add a reference to the particle system called destroyed particles. Again, this is serialized and private because we want to set it in the inspector but don't want it changeable. Then in our onTriggerEnterToD method, after we've spawned our new asteroids, we can also instantiate the destroyed particle effect. We pass in the reference to the particle system prefab and the current position of the asteroid. Quaternion.identity is used because we don't want to apply any rotation to this. Over in player.cs, we do exactly the same thing. Add the reference to the particle system called destroyed particles, and in onTriggerEnterToD, before we destroy the player, instantiate the particle effect in the same way as before. That's it. Back in Unity, we can drag on the destruction effect prefab to the asteroid prefab and the player and check out the game again. You can see now the asteroids are destroyed with a nice simple effect, and the same happens for the player too. Now you've got the core game mechanics sorted, you can start to add in other features. The first extra I did, but it was a little too long for this tutorial, was to add in an engine effect with the ship like this. It follows much the same principle as the explosion, but as a constant emission which plays only when you're pressing the accelerate button. See if you can get that working yourself. Other ideas include having 3 lives rather than restarting upon death, tracking the score, and finally that little spaceship that comes around occasionally to shoot you. I hope you found this tutorial useful in some way. As ever, the full code is available on GitHub and I've put a link in the description below. See you next time.